We're going to be doing something a little bit differently in this video, which is using a table to calculate some probabilities. Specifically, we'll be using this data table, which shows voting data from the 2004 presidential election with Bush versus Kerry. Our first probability we want to calculate is what are the chances that a random voter voted for Bush given that they are from Harris County? Now, an important word to note here is this word given coming up again. When you see that, that means that we can already assume that this following portion is true. So in this case, we already know that they are from Harris County, which actually limits what we have to look at a little bit. If we know they're from Harris County, then this row right here is the only data we care about, which makes this problem a whole lot easier. So specifically in this case, we're finding the probability that they voted for Bush, given they are from Harris County, which, if you look at just this row, there are 581 people who voted for Bush, out of, if you add these three numbers up, 581 plus 472 plus 5, we end up with 1,058 as the total possible options. For our second problem, we're going to do something a little more complicated, and there's actually a couple ways to think about this, so we'll look at both of them one right after the other. Now we're going to find the probability that a random voter was from Dallas and voted for Kerry. So that word given is gone. We can no longer just kind of box this off to a single section, which means this actually is either going to be dependent or independent events. They are from Dallas and voted for Kerry. Which, if we think about it, whether or not they voted for Kerry does actually seem to depend on where they were from, because the proportions are different in each county. So that makes this a dependent event, which means we'll have to calculate it as the probability of Dallas times the probability that they voted for Kerry, given they were from Dallas. Well, we can find the probability that they're from Dallas, if we do these piece by piece, pretty easily. Because the total number of people from Dallas, if you add up 345 plus 336 plus 4, is 685. And then that's divided by the total number of people that voted, which was 3,125. I should note here that all of these numbers are in thousands, so when I say 685, that's actually 685,000 people. So there's our probability that they're random voters from Dallas. Now the probability that they voted for Kerry, once we know that they are from Dallas, we can now kind of go back to what we were working with before, which is just looking at this Dallas row. So in this case, probability they voted for Kerry is 336 out of all of the Dallas voters. We see that 685 again. So the probability that we wanted, which was they voted for Dallas, or sorry, they were from Dallas, and they voted for Kerry, we said we could calculate as this multiplication. So 685 over 3,125 times 336 over 685. And when you do this math out, when you do the multiplication, actually these 685s end up canceling, which leaves you with a fraction of 336 out of 3,125. That's the first way you can do this, which in this case I think actually ends up being the more complicated way. Another way to do this problem, we'll change colors, is just to say, okay, well, what's the chance, what is a success case here? A success is that they are from Dallas and voted for Kerry, which is just this box right here. So that means our success options are 336. And then the total number of options is the entire voting population of these 5 counties, which is the 3,125 we got earlier from adding everything up. And then we've kind of immediately jumped to our same final answer that we got above. The reason I want to show you both ways is that in some cases the first strategy will be more useful, in others the second will be more useful, like we saw here.